Okay, does that look like the file that you would like me to work with today?
Yep.
Okay, all right, so can you give me a little bit more about details about what this exactly is and what would you like me to help you go through on this file?
Yeah, can you look at the layers?
Okay, let me go into the layer manager right here in Rhino. Okay.
Yeah, so the blue edges on there actually show what we want the part to look like. I know
Okay.
that people do like center a tool path with offsets, and this is what the part needs to look like. So we have inside cuts and outside cuts only,
Uh-huh.
and
Okay.
then we have the can you mouse me? We have Sharpie lines, which
Okay.
are I'm just hiding our GoToMeeting thing so I can see your screen here. Yeah, so the Sharpie lines, those are we actually do with a marker.
Okay.
That is center a tool path lines that are drawn on there, or notations to be used on the shop floor that we actually draw on with a marker. And then the
Okay.
X is also drawn in with a marker.
You mean
So
the engraving you're talking about right here?
no, under notes.
Okay, let me go to notes. Let me select the objects here.
The cyan objects will actually be written in with the marker as well.
Okay. Okay. All right.
And then the engraving is just Dakota, you could probably tell a little bit more about the depth of the tool used for that, but that's just a line, a circle that would be engraved into the plate. How deep
Okay.
do you?
It's just
Okay.
a 90-degree engraver at 0.015 depth.
Okay. All right. Perfect. Makes sense. So most of this would be like a 2-axis or 2D milling or 2.5-axis machining operations on this particular file. What I can tell here. So all of our configurations offer 2-axis milling. For if you're going to be doing parts that would be more like these, similar to these, you can do a lot of automation. We have what is a feature called knowledge base, where we can actually save the entire workflow of operations to a knowledge base, and it can program it. So you can set up like rules, even to automatically have the geometry selected for machining as well. And I'll go through that as we go through the demo here. So that's offered right from the standard configuration of our product, the knowledge base functionality. So let's see how we'll go ahead and program this part in here. So the first step we want to do is go ahead and establish the XYZ orientation and where the origin is. So if you take a look at the drawing here, it's somewhere way out in space right here, and your origin is right over here, right? You see that, sir?
Yep.
So we want to get the part moved close to the origin. And also you have some of these defined as text in here. You can see it's defined as text in Rhino as opposed to being as a vector geometry. So if you want to engrave them, you would need to convert them to like a vector geometry. So you can go ahead and click on notes, right click and say select objects. It'll pick all of them. And if you just do an explode command in Rhino, you'll notice that it'll convert them to vectors. You see that right there?
Mm-hmm.
But it looks like there's some sort of an issue with the with the conversion itself. Now, are these supposed to be in inches or millimeters? Do you know the drawing?
That should all be in inches.
Okay, so it looks like there's some sort of a scaling issue or the way this was created. So we may have to convert these to vectors and scale them down, because when I try to explode it, typically in Rhino, when you explode it, it should stay with the same height and letters text that you have. You can see when I explode it here, it kind of scales up right there.
Yeah, I think I know why that is, but we can deal with that later.
Okay, so you need to have it vectorized to be able to engrave, so just letting you know. So now let's go ahead and get these parts set up for machining. The first step we go is into the RhinoCam's machining browser. So when you go to RhinoCam and click Mill, it automatically displays your machining browser, which has 2 main tabs. You have the Program tab or on the left, and then Simulate tab to the right. So your workflow is working through each of these groups as you go from left to right.
Mm-hmm.
And then underneath this here is called the Machining Objects browser, which allows you to define tools. As you can see, I have a bunch of tools already preloaded. So RhinoCam will load the last loaded tool library for you. So you can build your own library of tools and load it, or you can load the standard tool library as well. And you can define tools as and when you want to add new tools to a library. So we have different tool types we support, starting with ball mills, flat mills, corner radius, tools for engraving. You talked about a 90-degree cutter. So we put in the taper angle, which is the include angle. So if I put in 45, the total angle would be 90 degrees.
Mm-hmm.
You have chamfer tools, taper, thread mill, face mill cutters, dovetail tools, fillet mill tools, lollipop cutters. You can also create form tools. And of course, you have all the drill tool types: drill, center drill, reamer, tap, bore, reverse bore. And you can create tools. You can define your tool numbers, establish the properties for the tool, and then also you can set feeds and speeds. You can also compute the feeds and speeds based on the material you're cutting, and the system can give you recommendations on the feeds and speeds to go with.
Okay.
Right? And all of this can be saved to a library, so you don't have to go through the process of recreating the tools for each and every project you're working on. Now, there are several ways you can establish the origin. So one of the ways I could do it is basically move the origin to the origin in Rhino using the transform command. So I could basically, if you want to just basically put a box around it and move it, you could do that in Rhino, or you can use the tools that are available to you in RhinoCam to move it to the origin as well. So the workflow here is go through the machine definition first. You specify the type of operation. So for 2 and 3 axis, it's automatically set to 3 axis. So there's no additional parameter that you need to set in here. And then you go ahead and select the post processor. This would be the machine tool that you're going to be outputting the code for. Do you happen to know the name of the machine or the controller that you need a post processor for?
Are you talking about the multicam?
It's a multicam. Okay, so
Yeah.
we can go through the list here. We have post from multicam. I'm going to select one from the list. I also have a post that's called revision 1, where I made a few edits that'll output the M12 and M22. They have what's called like a 3D device on and off. So that's included in the post right here. And then you can set the output extension to be .cnc. You can just select add new and put in an extension .cnc. The extension will automatically stay right here. And there's your post processor. So the next step is to create your stuff. Sorry, go ahead.
I have a question. If our post processor does not show up on that list, how do we go about getting it on there?
We'll get you a post processor for the product. When you get the copy of RhinoCam, we'll have a post processor for you.
Great. Perfect.
So we configure posts, we tweak posts, we edit posts for our customers all the time, so we can help you with it, not a problem. So the next step is to define your stock. And when you click on copy box, it automatically computes the minimum size of stock that you need for this part right here. So now if you take a look at this drawing here, I can actually go ahead and move this to the origin if I would like to. I could say align, set world, set to part, and I can choose what corner I want to put the 0002, right?
Yeah.
So I can say I want to take the southwest corner, put it to the origin right there. So it's going to move everything except the text right in here, as you noticed it, right? Because it's not a vector geometry, so it's going to leave the text there. So for now, I'm just going to hide the notes layer. Would that be okay?
Yeah, we're definitely going to need to sort that out because we need to know how that's going to work for us, and we would like your help on that. You need to
explode it to convert it into a vector geometry in Rhino. That's what we would have to do. One of the ways I could possibly try doing is using a command called duplicate face border in Rhino. Let's try that in here. Let me hide this information. So I can try using duplicate face border. Okay, so in order for me to explode this, do you know how this was created in originally?
It's just using the text command.
Okay, so the explode command in Rhino, explode text. See, the explode should do it, but it's for some reason it's scaling it up. So we'll have to talk to McNeil to see how we can explode it without having to scale it. I have not noticed this on other text geometries, so I'm not sure why it's scaling it up. I'll have to check with McNeil. But once you explode it, we can engrave these geometries. Okay.
Yeah, because we want the text to be a single line.
Okay, so if you want it to be a single line, then we actually have a text that can be created as a single line. So we have a text for Rhino. It's called a single stroke font, and let me show you how to do that here. So I'm going to undo what I just did.
Yeah, we might be able just to change the font type.
Okay, so let's go ahead and say edit. Okay, you want to create them as curves. Let me see here.
Any duplicates, or is one cheaper than the other?
So we might be able to.
Yeah, so you created this as a text in here, right? You see the height, everything, it shows up right here. Yeah. So rather than creating as text over here this way, you need to create this as a text object. So you need to redraw it as a text object right in here. Okay. And then you specify the text type. Type in the text. rather than selecting them as, you need to make sure you select them as curves. You select allow single stroke font, and then you basically pick the font in here. We have a font called MecSoft font. You pick that, that's a single line font, and you select this and give it a height for the text. What is the height? Half an inch.
0.5.
0.5. So you put in the height, and now when you create it, you see it creates this one. It shows it, you see it shows as a double line font right there. So let me go back and redo the text in here. You need to select the font as MecSoft font 1. And then you select allow single stroke fonts, and you'll now notice that it creates as a single line text.
Great.
So you would need to actually define these as a single line text, and then you can do an engraving with it, okay? So rather than creating it this way, so this one is a different type of text what you created. So you need to change it to, use the text object command in Rhino, and then you can create it as a single line text.
Great.
Okay?
Okay.
All right.
Thank you.
So for now, I'm just going to skip the text, because we've discussed how we want to define them or create them in Rhino. All right.
Yeah,
All right. So we got this in here, the geometry. The next step is we'll go ahead and build our stock. We'll say stock. And this gives you the length, width, and the height. Does that look right? The length and the width, 149 inches and 52 inches.
Mm-hmm.
Okay.
Yeah.
So I'll make it slightly larger. Maybe we'll go 150, or and then we'll change it to maybe like 53 inches, or we can say 152, and then maybe 53 inches or 54 inches. And we'll give it a height. What would be the thickness that you want to use?
0.19.
0.19. Okay. All right. We'll create the stock. As you see, the stock has been defined. The next step is we want to align the stock to the part. We would pick align, Z alignment. We want to have it flush to the top. So if you take a look at it here, you can see that the text is flush to the top, and then have it centered in X and Y. Okay?
Yep.
So there's material being left all around the part, so we can go ahead and, not leave any factory edge, so we're going to machine it out.
Mm-hmm.
So in the next step, we want to put the 0, 0, 0. Where would you like to establish your XYZ origin?
Where it's at, it's fine.
Okay. Or do you want to move it to the corner of the stock material in here?
Yeah, that's more preferable.
Okay, so we'll do set world coordinates, set to stock, higher Z, southwest. So that basically puts your 0, 0, 0 to the top of your material in the Z, and then to the southwest corner, which is going to be your lower left corner for XY origin. Now, if your router has more travel on the Y compared to X, then we would need to rotate the part out by 90 degrees. So in this case, we have assumed that we have more travel on the X.
Correct.
Okay. All right. So we got this set up in here. The next step is to, program our toolpaths. So you'd want to cut the inside of these two shapes, right?
Yep.
And then these as well?
Yep.
Okay. And then the outside of this particular shape.
Yep.
All right. So what we can actually do is to make our selection process easier, I can, the ones that you've defined here, you call them edges, right?
Yep.
So you can actually, if you wanted to just put them in different colors, we can change the colors in here. I can just right click and go to properties, and I can say this one, rather than by layer, I want to use a different color. I'll just pick green for our discussion here, okay?
Okay.
So we're going to go in to say first we want to do a profile cut. We'll pick select curves. Now rather than having to go through the process of individually selecting them, I can use the select by color option in Rhino, and I can pick the target color as this one. It'll automatically pick all objects of that particular color. And then right click. So all 4 geometries are now selected. I'm going to go pick a tool for it. What size cutter would you like me to use for the profiling? 1/2 inch end mill?
That's fine. I usually use a 3/8, but I don't.
3/8. Okay, I'm going to go ahead and add a 3/8 in here. So I'll just change the tool name to 3/8. I can then establish my tool number, feeds and speeds, save as new tool. It says tool number is being repeated. Do you want to use a non-repeated tool? I can just say no for now. So it's tool number 1 is set to 3/8. So now I got the 3/8 tool in my library. Feeds and speeds are being loaded from the tool. You can see that the clearance is set to automatic. So this is your safety plane for all your transfer motions. You can also change that. You can say go stock max plus maybe a ½ inch, for example, if you want to go ½ inch above the maximum height of the stock. In the cutting, I could say I want to climb cut on the inside, and then in the cut levels tab, I can specify how deep I want to go. So your material is 0.19, right? You want to go maybe 100 thousandths deeper into your spoil board, or you can just say 0.19 or 0.2, for example.
0.2 is what I usually do.
And then you want to take it out in one cut, or you can break it up into like 2 cuts of 100 thousandths each. So you have the control right here. Okay. And then you can do entry and exits, how you want the cutter to lead in and lead out. If you just want to do a plunge, you set it to none. It'll just do a plunge, cut it. And then you can do any sorting and advanced cut parameters right in here. You can specify to do a sort based on minimum distance and then generate. So this basically gives you your profile cut for the inside. Okay. So it's cutting the inside shapes right there. And let's go run a simulation. So I can go to the simulate tab, select the operation, and click on play, and that shows your material removal simulation, cut material simulation. You can see it's going down to the depth that you put in right there.
Yep.
If you want to do bridges and tabs, we can also do bridges and tabs so this piece doesn't fall apart. We can add a, bridge so the part stays intact if you don't have a vacuum holding and you want to do it. You can also speed up your simulation right in here.
Okay.
So now that we did the profile for the inside, the process would be very similar for the outside in here, right? So I'm just going to make a copy of this. I could do right-click, copy and paste, or I can use just Control-C, copy, Control-V, paste. I'm going to rename this to inside, and I can rename the second one to outside. And then I can double-click. All I'm doing is dropping the boundary I selected for the insides. Select curve edge. I can either select by color or select, it was just one geometry, just pick it right there. And I'm just switching from inside to outside in here, and then generating it. So all the other parameters stays the same. And you can see if the cutter was too big, you wouldn't have been able to cut this feature in here. So it looks like the cutter is able to get in.
Mm-hmm.
Okay. So doing it in 2 steps. Now, would you like to go ahead and engrave these letters in here, or the shapes that you have?
Oh, they're Sharpie, but
okay. And what kind of tool do you use? Like an engraving bit, like a V bit for the Sharpies?
No, you literally use a Sharpie.
It's a marker.
It's like a drag diamond almost.
Felt tip marker.
So, so would it be using like a milling operation that you would do for marking it, or is it something you do manually, or?
No, it's a milling operation. You just set the depth to 0.015, 0 RPMs, and 1 pass.
So we do an operation called engraving for that. And then we can say select the geometries. Now I can either use select by color, or I can just go to the layer called Sharpie, right click and say select objects, and it picks all the objects that are on the layer. So you see how the selection process is much easier here. You don't have to go through a process of pick each of them individually. So now they're all selected. You go to your tool, and here you can say you want to use like an engraving bit, like a V bit in here, right? And we can put the tip to be like the taper angle. We can make something like a 5 degree, which looks like a pencil, right? Similar to. So I can specify the tool length here. I can say when it's going to be like 2 inches length. I can call this 5 degree. You can specify the angle right there and do a save as new tool. Okay, it says my tool definition is now valid, so I got to change my, you can see I got to change my shoulder length, right? I can set my shoulder length to be just like 1/4 of an inch. So now the tool diameter would change. The taper angle is 5 degree. I'll do a save as new tool. So I got the tool defined. In the cutting parameters, I specify how deep I want to cut. You said it's 0.015?
Negative. Yeah, that works.
Okay, so we just put in an absolute value. We don't put in a negative or a positive. The total depth would be determined based on where your 0 is. So it'll just go down to the specified depth. It's just an absolute value that you put in here. Okay?
Okay.
And then you can specify your sorting. So sorted starting from the lower left corner, we can say upper left corner, and then generate. So that's going to go ahead and give you an engraving path. And now I can make this my very first operation in here, drag and drop it. So you don't want the outside cutout to be done before you process that other information in here, right?
Yeah.
So it's going to go in and, program that to the depth that you put in there.
So what's that?
Right? So you can see right there, it's going down to the depth that you put in.
So how did you specify a 0 rotation on that?
Well, we got to specify in the post, we can say RPM as 0. We can put it in here. Speed, spindle RPM. We can set that to 0.
Yeah, and that won't cause any issues.
Well, it'll output a 0 RPM in the output. Unless you can say, show me a posted code what the output needs to look like, I can take a look at the post. So if I post this out, it's going to output an RPM of 0 as the post is set up to 0 RPM. So you can see it says G97S0.
Yeah, great. That's what we want. Because it's literally a felt tip marker we're dragging across the material.
Yes, I'm putting an S0 right here, spindle RPM. So whatever you program gets output right there.
Great.
Okay, and then the tool number I just left it at 169, whatever tool number that you want to call it. Okay, so we got the Sharpie done. Then the next thing is we want to do the engraving. So I'm going to repeat the same operation, copy, paste. And now I'm going to change this boundaries to the ones that are on this layer called engraving, select objects. And then we'll change the tool, and you wanted to use the 90-degree cutter for that. So we'll pick the V-mill 90 degree. And then you can specify how deep you want to cut for these.
Yeah. So I haven't seen on their like start point or tool order or part order. Can you do that?
Yeah, the start point basically automatically uses the start point of the geometry that you have in Rhino.
Can you manually change it?
You can change it right here. You can use the command called curve seam in Rhino and to move the start point around. So curve from objects, adjust closed curve seam. And you can actually drag the start point around.
Oh.
And RhinoCam automatically uses the start point of the curve for operations like engraving, profiling, chamfering. So it uses the start point. And then when you give it a depth in here, so let's say we want to go 25,000. So how deep would you like this to be cut?
The 0.15 is fine.
0.15, 0.015?
Yeah, sorry, that one.
Okay. All right, and then the sorting, you asked me like, I can choose how they want to start. If I pick no sort, it'll use the order in which you selected. If I pick sort from the lower left corner, so it's picking from the lower left and try to find the minimum distance. I can say go with a directional sort, and I can say go with a zigzag from low to high. So it'll go all of these first, then come back this way.
What about manual? If you want manually select
Manual is you set no sort, and then you pick the order in which you want them to be selected.
Okay, so it'll prompt you to do that.
Well, when you say no sort and then generate it, it'll just engrave them in the order in which they were created or they were selected. So here you can see there's no sort order. I can go back in here, remove, and I can pick the order. So I can say I want to go 1, 2, 3, 4. So it'll basically use that order in which I selected it. 1, 2, 3, and 4.
So you select the parts in the order. I would just start by.
So no sort will use the order in which you select it. But if you go ahead and say you want to do sort based on minimum distance, which means it'll automatically look at the 2 or more start point of 2 or more geometries, and it'll use a start point to define the sequence.
Okay.
And then again, I can run the simulation here. So we got these operations simulated, and then we have the profile for the inside, profile for the outside. So now based on the parameters we put in, like the feeds and speeds, all the information that we put in here, you will notice that it gives you an estimated time for machining it information. So based on the feeds and speeds, so you can see that the engraving, the first one is going to take about 25 minutes because I'm only going at 25 inches per minute. And the last one, the profile cut outside, is going to take about 22 minutes if you're cutting at 40 inches per minute. You can always go back and update the feeds and speeds, and then it'll update the estimated time for machining.
Yeah. So, sorry, another question. So instead of doing a separate operation for inside outside cuts, can you not have those on the same operation and just have your tool direction on the geometry itself?
Yes, we can do that. So what we look at is this, there's 2 choices in here. One of the options here is in the cut parameters, we have cut side to be right side or left side of the curve. The other option is use outside or inside. Okay, so if you wanted to do it in one operation, then what we can do is we can take a look at the direction of this curve. If you look at the direction, this one is going counterclockwise, right? You see that?
Yep.
Okay, so, and we want to make sure that these ones are going clockwise, then we can program all of these in one operation. So if these are, because you can choose cut right or left, then you can do right or left. So it'll basically keep the cut at the right side or the left side. So if I flip the direction of these, I'm going to flip these. So this one looks okay here. Now I can go back in here and make just one operation, and I can select all of these, and instead of using cut right or left, cut outside or inside, I'm going to choose cut start side to be right. So you'll now notice that it's cutting on the inside for these, and it goes on the outside for this one. So if you choose cut right or left,
can you zoom into the circles?
sure, I'll zoom in right here.
Just to the circle. Is that cutting? It looks like it's cutting on the outside.
It's cutting on the inside of the circle. This is a geometry. This is a path, cutter path.
Oh, okay. All right.
This is the red line you're seeing is a transfer mover rapiding from one to the other.
Yeah,
so now if I go ahead and run a simulation here, you'll see it's cutting the inside of the circle. So that's how you can. Yeah, so in our the next version that's going to be released towards end of the year or early next year, we'll have an option to alternate between the directions. If you pick outside, it'll do the inside for this. So in 2019, we either look at the direction of the curve or we can pick outside or inside. So if you want to do both in one operation, then this is the way you can do it. You can reverse the direction of the inside curves to the outside curves, and you can do it in one operation.
Do you know how to do that in Rhino?
It's a command called dir, analyze direction, and you can do a flip. So go to analyze direction. It'll ask you to select the object, and you can just do a flip all, or you can just click on individually. It'll let you flip it.
Yeah.
Okay. So now I can go ahead and delete these two operations out right here. Now it doesn't matter whether you program it as one operation or two operations. When you output it, the code is still going to be the same.
Well, my concern is I'm not cutting one part. I'm cutting 100, 200 parts per sheet, and I have a lot of inside-outside cuts, and I don't want to have a bunch of holes in my sheet, and then for doing inside cuts, and then try to do all my outside cuts in the next pass.
You want to do it in one operation, inside and outside.
Yeah.
Okay. All right.
So I don't lose vacuum.
Makes sense. Okay. So you can do it this way by using the direction, and you can flip it over. Now, if you want to nest parts to a sheet, we have a nesting, module that's included with RhinoCam. So you can nest multiple parts into a sheet using our nesting module.
Can you show us how that works?
Absolutely. Yeah. Let me go ahead and save this out here. I'll just do an incremental save so I don't modify your original file. Okay, so all of the CAM information that we programmed here is saved with it. Now, there's one thing I wanted to point out here before we do a nesting is, now these operations that we programmed in here, we can actually take all of these operations and then save this to a knowledge base. The knowledge base is considered like a template of operations. It has information about your tool, the feeds and speeds that we put in, the parameters that we put in, the cut depths, all of this can be saved. We can save all of this information into a knowledge base. So when you have parts that are similar to these, you want to program them, you don't have to go through the process of recreating the operations by going through the menu in here. You might just load the knowledge base and then basically program it. Now we can go one step further by even making the selection of the geometries. We can automate it in a knowledge base. So one of the ways we can do that is by applying rules. So I'm going to go ahead and load the knowledge base in here. So let me go ahead and delete these operations that I had created. So consider that you just started out with this part and you want to program it. I'm going to set up rules in here. For the first one, I'm going to say select all objects that are on layer. In this case, I'll pick the layer called Sharpie. For the next one, I'm going to say select all objects. I can either apply it based on a layer or based on a color. So in this case, I'm going to say apply for engraving. Then finally, I'm going to say for the profile, select all objects based on layer. Is it edges?
Yep.
Right? I'll apply that right there. So now I have put in rules in here. Let me save this out. I'm going to just call it with rules. Now I'll show you the difference. Now if I just go ahead and load my knowledge base, the first one, this one brings in all the operation parameters for you, but you can see there are no geometries being selected. You see that?
Yep.
It has all of your feeds and speeds and everything in here. But you got to then go ahead and say select curves, and you can either pick them graphically or you can use them by layer or by color. Now, the one I created with the rules, I'm just going to go ahead and load the knowledge base with the rules on it. And you'll now notice that the engraving automatically picks all of those geometries that were on the layer. So this is automation, and it comes right from our standard configuration. So all I had to do was right-click and regenerate. The toolpaths are now generated fully.
I have a question.
Mm-hmm.
For the lefts and right, is there a way to build that into the knowledge base as in the form of maybe a script or something where it can select all of the items on the edges layer and then flip the directions
That's something you
accordingly?
can do it in Rhino. Scripting is available in Rhino. And there's no scripting built into the CAM. We use knowledge bases in the CAM part of it. So in Rhino, you'll be able to script it, and you can probably talk to Rhino folks, and they can tell you how you can have the direction for the outside and the inside in opposite directions.
Great.
So do you see the power of the knowledge base right in here? So how we were able to, make the selection. So this is available right from our standard configuration.
That could come in handy.
Yep. So I see that you already are structuring your objects on different layers. You've done the groundwork here. So that's just extension of that into the machining. Okay.
So I'm going to back up and just recap on that and make sure that I'm hearing you properly. So you could open a Rhino file, and then when you go in and insert the knowledge base, you load the knowledge base, and it will automatically put the proper items onto the proper tool pathing.
Yes, if you, yep, that's right. So basically what we did was we first programmed one of the parts, and then we established rules in here, as you see it, right?
Yeah.
We said for the engraving, the selection rules are based on objects that are on layer Sharpie. And for this second engraving operation, we said select all objects on layer engraving. And for the final one, we said select all objects on layer edges. So this information is now for selecting the objects or geometries for machining is going to be saved in the knowledge base. So when you open up a new file, it could be any shape that you're cutting. All you do is open the file, you define your stock, you load the knowledge base. Now stock is mainly used for simulation. You really don't have to create a stock in here. You just load the knowledge base, and once the knowledge base is loaded, if you select the operation, you see the geometries are automatically highlighted. If the geometries of the layer do not exist, then it's not going to be able to select anything in here.
You like
right?
that?
So this is available right from our standard configuration. This is like steps for automation, automating your workflow.
That's great.
All you do is generate. Now you can set it up, and the person who's going to be doing this, all he has to do is just a few button clicks to do it. So you have built the intelligence in here. You define the tool for it. You set your feeds and speeds, clearance. All of this information is built in here.
That's great.
Okay. Now let's look at nesting. Any questions so far?
Is there pocketing and whatnot? I haven't seen that.
Yep. We have pocket operations in 2-axis. We have
axis, got it.
Profiling, engraving, V-carving. We have slot machining, chamfer, filleting, hole pocketing, hole profiling, thread milling, T-slot machining. The remachining is offered only in the Pro. All of the methods that you see here, from roughing to the knife cutting, is available right from the standard configuration. And you get 3-axis machining. There's 5 different methods: roughing, parallel finishing, horizontal, which is like Z-level finishing, radial and spiral machining. These are included in standard. Plus you get hole machining, drill, tap, bore, and reverse bore with the standard. Now we actually have a feature list. If you just go to the help, either within the product, you go to configurations, and I'm going to expand the list here. You'll see the methods that are offered in each configuration.
So what's the so we're probably looking at the standard. What's the standard cost again?
Okay, I will certainly get that information to you. So all our information is published on our website here. If you go to RhinoCam, go to website. Let me bring this up. Just go to our e-store, and you go to RhinoCam. And then go to standard. So the standard pricing you'll find right here. And then if you do not have a copy of Rhino, you can get Rhino 6 right here. And then we recommend adding what's called the annual maintenance subscription, which not only gives you premium support where we can log in to help you troubleshoot it, it gives you access to monthly webinars, gives you access to what's called a CamJam video guide, and it'll include the 2020 version upgrade. So,
Here, can you go back one page?
Sure.
Please. Do you seeing what you've seen here, would the Mill Express work for us?
Well, the Mill Express does not include knowledge bases.
Oh.
So the version that includes knowledge bases is from the standard. So the Mill Express includes 2-axis facing, pocketing, profiling, engraving. The toolpath methods are included, but the knowledge base functionality is only offered right from standard configuration.
Okay.
So the answer is you could do it, but then you wouldn't be able to automate your workflow.
Okay, great. Thank you. That answered.
All right. So let's look at the nesting module. So I'm just going to go from RhinoCam Mill to Nest. And we have 2 different types of nesting here, true shape and rectangular. So true shape basically inherits the true shape of the object, and it'll basically nest them in here. Now you can specify select the sheet. So you can either draw a sheet in here. So for example, I can say my sheet size, I can just go ahead and type in 00. Then I can specify how big the sheet is going to be, right?
Yep.
Do you happen to know approximate size of your sheet? Is it 5 by 10 or 4 by 8 or?
20 by 6.
20 inches or 20 feet?
20 feet. 240 by 72.
240.
72.
Okay, right. So we got this in here, and now I can select curve. I can just grab this as my sheet. Then I can go to select parts to nest, select the parts. Now, once you establish all the direction, everything in here, RhinoCam will maintain that when you nest it. So you can see it shows there's one part and so many holes right here. And then I can specify how many to nest. So for example, if I put in, let's say 4 of these, right? Okay. I can specify the orientation step. You can choose any orientation of, it's right now it's set to 90 degrees, but you can put in any orientation of maybe 15 degrees or 20 degrees or 45, any orientation of 45, you can nest it in here. You can choose the nesting parameters, distance between part to part. You can set it right here. You can say the tool is going to be 3/8, so I can say ½ an inch. And then distance from the edge of the sheet to the part, I can say leave 100 thousandths. And then when I say execute nest, you can see there's only one part it can fit in here, right?
Yeah.
So if we make the sheet bigger, we can probably fit more parts into it. So if you go back in here and say estimate number of sheets, it'll tell me I need 4 sheets to fill this job.
Okay.
So I can say update the sheet count, and I can also say, place it along X or along Y, and specify the spacing. So basically you have sheets 1, 2, 3, and 4. And then when I hit commit nest, it's going to output them as layers for each sheet. So basically we have 1 layer for each sheet. And then we can automate the programming again. So you can see it maintained the same colors. So you can automate it.
Yeah.
So the nesting comes included.
Why did it keep the original up on the top?
Well, we don't delete the original. So you can actually output these as separate layers. So that's one of the options we have, is we can export each sheet to a separate Rhino file if you want to do it that way. So typically we don't remove the original part. So you can just go ahead and hide it in here.
Okay.
So we do not delete the original part. So we leave it in the original location placement the way you have it.
You could do it in each file that's
Yeah, you can
export.
export each sheet as a separate file. So there's an option here. You just need to give it a folder path, and then when you click export, it'll export each sheet as a separate Rhino 3DM file.
Do you have a more complicated nesting example you could show us?
Absolutely. I can go through that here. Give me just one moment. Let me try to look for something here. One moment, please.
Yeah, no worries. Take your time.
Any other questions here?
No, not really. I don't know.
Okay. So you could nest, pretty much any type of geometries, any closed shapes, 2D geometries in here.
On the orientation degree, can you just put 1 if you don't care what? So that would just tell it any degree or 0?
Any degree. You wouldn't be able to put 0 because 0 wouldn't work. So you had to be.
Would have to be 1.
1, yeah.
Okay, that's what I thought.
It just takes longer time to do it because it could be any 360. There's basically 360 possibilities, right?
Yeah.
So the smaller the number that you put in.
But it'd be the most. You have the best yield though, right?
Okay, so here you can see that we have different types of shapes in here on this example. So you click on select curves. So in this case, you can have your sheets, they not necessarily have to be rectangular. You can even have sheets that could be, like remnants.
Yep.
And then you go to select parts to nest. You can click on select parts. And you can see it automatically groups as part and the whole. And then let's say you had something like some text in here. Let me change the font to Arial. Let's consider, okay, that's a little too small. I'll change the height of the text in here to maybe 2 inches. I'll use a grid snap to place it right in here. I'm going to throw in a rectangle around this. So consider that I would like to nest these parts as well. So typically in nesting, there's only one layer, like it's a part and this is a whole, right? Now everything inside this would not be considered as the same unless you select this checkbox as used for engraving and sign making. So for example, if I go back in here and select all of these, you'll notice that it creates so many different parts, 13 parts in here. But when I select use for sign making and engraving, it'll treat everything on this particular part inside of this as one entity. So it changes the behavior as parent and child. So anything inside the outermost shape will be treated as, so it'll maintain the same uniformity. So if you have some text that you need to do, you can specify it. And you can also put in the quantity of each part. You can select them, you can enter the count. You can also set a priority for it. So if this part needs to be nested before the other parts, you can put the priority as 1. So as you change, as the numbers go up, the priority drops.
Okay.
And you can also say, for example, you want to make 5 of these, and you want to have all parts of 5 quantity. You don't have to go and enter 5. Right click and say make all the same. It'll set all the parts of priority of count of 5. But the priority is still 1. You can specify the angle. I can say any 15-degree orientation. You can allow mirroring of parts. Now you can say, execute the nest. So you can see it's executing the nest right there. I pulled into the sheet. And I can do a commit nest. Or I can say give it a folder and export it to path. Now I can go back in here and change the quantity here. So for example, on this one, I could say I want to go 25. And this part I can change it to 15 or 50. Then I just go back in here and say execute the nest. You can see right there. Okay.
Okay.
And then you just basically go ahead and do a commit nest. It'll basically put it on same layers.
Where would it tell you? So can you go back to changing the numbers and can you make one of them like 100?
Okay.
And then execute nest. And I just want to see what it tells you.
Yeah, so if you go to report, it'll tell you the number of quantity of each part. So you can see that it was not able to nest all of the parts. you can see there's only 5 and 8, total of 13 of part 1 that was nested, right?
Okay. And then it will show you how many
Yeah.
sheets.
How many sheets are required is you just go back in here and say estimate number of sheets. So it'll tell you that if you use sheet 1, you need 3 of them. So you can say update sheet count. So now if I say execute nest, you'll see that everything is going on one sheet right there. And then if you do a report, so if you add these up, it makes it to 100.
Can you show the rest of the sheets?
Yeah, I can right here. Sheet 1, sheet 2, sheet 3. So I put them to stack. They're stacked right on top of one another. If I can choose, I can go back in here and say I want to put them along X, give it a spacing. So now you can see they're going to be laid out side by side.
Okay, I see. There's no dialog box that pops up to tell you, by the way, you didn't get all of your parts on the one sheet.
Yeah, if you, no, it doesn't say that. If the parts were not nested in here, like the entire part was not nested, it'll list up right in here. List up on unnested parts. But if it only did, like, let's say 20 out of 25 parts, then you got to go into the report to see it.
Okay. If it nests them. If it doesn't nest them all, it'll show up there.
Right. If it doesn't nest them all, then it'll show it right there.
Okay.
So for example, if I draw a sheet right here, let me go ahead and just throw in something. Okay. So now let me go back, remove all, select curves. So now you'll see that these are the parts that never got nested in here.
Yep.
One, they never were able to fit in, right?
Got it. Okay, thank you.
Okay, all right. If there be any other questions, I can help you.
No, we're both shaking our heads.
Okay. All right, well, if you do have any questions, you're welcome to give us a call or send us an email, and we'll be more than happy to answer them for you.
Okay. Could you send us over a quote?
Certainly. What I'm going to do here is have my coworker send an email to you with all the details that you need. Would you need a copy of Rhino, or would you just need Rhino Cam?
No, we got we got 6 seats
all right,
of Rhino.
So you need Rhino Cam for Rhino 6, is that correct?
Yes.
Okay, all right, certainly we'll do that then. Were you looking for one or more than one copy of the product?
Just one.
One, okay, all right, we'll certainly do that then.
I did just think of another question. So can you show us how this will integrate into our machine?
Okay, well, let's go back into the file we were working on earlier.
What do you mean? Like, what do you mean?
When you run it, this one's.
Yeah, so what you do is you do a post process from RhinoCam like we did it earlier. So that's your posted code right here.
Okay.
You take this and you transfer it to your multicam's software interface. If the multicam software is on a different machine, if the computer is on network, you just put it on a shared folder, you access the CNC file on the computer, or you transfer it via an external drive like a USB flash drive or like a jump drive. You just transfer
Dakota's here nodding. He's understanding it. He's got it.
All right. So it's as simple as that. All we output is the output file. It's an NC file. It's in a text file format, so you can copy a file from your desktop or any folder out to your CNC machine.
Okay, so if you guys have to do any work with us to get us to talk to the Multicam 5000, is that an additional charge, or does that come with the package?
The post processor would be included with the product.
Okay.
So we have the post pretty well ironed out. So we have customers using our product with multicam CNC. So we'll get you the post. And if there's any changes or tweaks that you need us to help you with, we can certainly do that. That will be part of support.
Okay, great.
All right. All right, gentlemen. Thanks for your time.
All right, thank you.
I will get you a copy of this recording, and then we'll go ahead and edit and publish it on YouTube as well.
All right, perfect.
We'll get one that's unedited, correct?
That is correct.
All right, thank you very much. Appreciate your time.
Thank you. Thank you as well.